David Spears, Civil Engineering Instructor at Texas Tech University, talking about CE 2301 statics. We've got a moment of inertia problem by integration. In this case, we have an x-axis boundary, and therefore we're going to use a vertical strip to simplify the integration. The goal is to find Ix and Iy. We've got a curve along the top of y is equal to x cubed divided by 4. And along the x-axis, which is a boundary, it runs from 1 to 2, so it's the shaded area. And we're going to find, let's find Ix first. Okay, because we have an x-axis boundary, we're going to use a vertical strip as our differential element, dA. It's a rectangle of base dx and height y. So its area is y dx, but we're going to have to do a sort of a trick to integrate with respect to the x-axis. What we're going to use is the trick. It's really not a trick, it's really a legal mathematical maneuver. If I have a rectangle with an axis on its base, let's call it the x-axis, and its base is b and its height is h, the moment of inertia about the x-axis is bh cubed over 3. Okay, in this case, we're going to say that's our differential element. And we're going to say that dix is, based on this, the derivative of the moment of inertia of a rectangle about its base axis is, well, in this case, b is equal to dx, and h is equal to y. Therefore, dix is equal to, take the dx over to the right, and y is h, so it's y cubed divided by 3. So this is kind of a trick, but it's kind of a simplification. It really is just simplification makes this problem easier. Therefore, let's say Ix, instead of it being, it's really equal to y tilde squared, the integral of y tilde squared dA. But that involves the parallel axis theorem, so we're going to use a simplification. We're going to say it's the integral of dix, which is equal to the integral of y cubed over 3 dx. And in our case, y is equal to x cubed over 4. So let's take that first 1/3 out of the integral, put it out here because it's a constant, and I've got the integral now of x cubed over 4, which is what y is equal to, but I've got to cube that, and it's with respect to the x-axis, dx. So let's take that 4 cubed, 1/4 cubed is 1/64th, so I got 1 over 3 times 64. That's another constant. Let's get rid of it. And x cubed is x to the 9th dx, which is equal to 3 times 64 is 192. And evaluate x to the 9th is an integral, and it's x to the 10th over 10. So it's 192 times 10 on the bottom, x to the 10th. And I'm evaluating from x equals 1 to 2. Just should add in all those integrals. And shrink a little bit, and that evaluates to, at 2 it's 0.533. At 1 it's equal to 0.0005208. And therefore it's equal to the difference in those two, which is 0.5328 inches to the 4th. These are all inches. Now Iy is a little bit simpler. We're going to use the basic integral of Iy is equal to the integral of x tilde squared dA. Well, x tilde is x from this relationship up here. So it's equal to the integral of x squared, and dA is equal to that rectangle y dx. So substituting in what y is equal to, and I get an integral of x squared times y, which is x cubed over 4 dx. And that's equal to 1/4 integral of x to the 5th dx. I'm going from 1 to 2. That evaluates as 1/4 times 6 times x to the 6th power, evaluated from 1 to 2. And I get 2.666 for the top, 2, and for 1 I get 0.0416 repeating. And once subtract 1 from the other, and I get 2.625 inches to the 4th. That's the answer.